So I just want to make a quick video on a recent forum post about the segment anything model and the implementation this particular user, Ko Sugawara, if I'm pronouncing this correctly, had done to enable QuPath users to use SAM um, through the comfort of the QuPath GUI. So what this extension essentially does, and if I can get this video to play again, is you can draw a rectangular annotation around whatever it is you want to segment, and it'll essentially pass that over to Sam. Sam will attempt to generate a binary mask from this, and yeah, no additional training data is required, which is one thing that is relatively unseen in the field of digital pathology. The ability to essentially infer a model without having to train it specific to your own data set, or at least a curated data set of similar images to whatever it is you want to analyze. So I don't want to spend too much details in the technical aspect of it, but you can find this forum post and I'll link it in the video as well. There's an extension you have to install, which is as simple as drag and drop. And you also have to create a Python environment with a few libraries and other things installed in it. What this essentially will do is host a server, and the server is what what QuPath will pass the rectangular annotation coupled with the underlying image data currently shown in the viewer. Do this for segmentation, which then gets passed back to QuPath, and as a result generates your segmentation. So I'm gonna demonstrate this on a few images I have, and most if not all of these are publicly available, just to see the kinds of segmentations we can get going. So of course the first thing you want to do is actually enable SAM, and it's very early on in the plugin's development, so you'll have to enable it every time you go over to a new image or even a new project. But yeah, let's give it a shot. So most common request in here is segmenting tissue. Let's see how well it does. A rectangular annotation, generally around your tissue, does a pretty good job. Another thing to note is that the data being passed to the segmentation, at least from my understanding, is not the original image data, but whatever is being rendered in the viewer. So you can see that, the outlines are somewhat smooth, somewhat continuous, but if I were to try this again at a much lower downsample factor, now the lines are a little bit more jagged, for lack of a better term, or coarse, I guess you could say. It really depends on the scale at which within the viewer you currently have zoomed in. That also dictates what structures end up getting segmented. So in this case, I have no idea what this round circular structure might be, but let's see how, or what'll happen if we pass it over to Sam. Yeah, it segmented the structure. Now, this could be of interest to someone studying whatever it is going on within this, perhaps immune cell activity in a particular region of the sample. Let's go one step further and take a look at individual nuclei. Because we're only going to be using nuclei, let's turn on only the counter state responsible for identifying nuclei, in this case DAPI, and I'll turn it on to a grayscale channel just to make it a little bit easier to identify. Let's get rid of this annotation and draw a quick square. Nice. Not perfect, but this is a great way to label your own images if you wanted to train the model of yourself. In the past, you used something like a wand tool and kind of rely on intrinsic and real-time edge detection, which is never really perfect. But in this particular case, you can just draw a square around your nuclei. Now, it might not do a good job of segmenting two separate nuclei, but this is a faster way of labeling your data set. Another common request is detecting tissue. So, weird. There we go. We've got multiple tissue sections on the slide and we want them to be analyzed independently. previously what you would do is you use something like the wand tool at low resolution, not that low, and, quickly contour your tissue sections. If we use if we use SAM, well, it'll only generate one object at a time. So if we were to say do these two things, I don't believe it would generate two separate objects. I forgot to restart SAM. Let's give it a shot. Yeah, so only detected this one object. However, the quick and dirty fix is to just do a rectangle, very loose rectangle. It doesn't have to completely encapsulate your tissue section. Essentially generate a binary mask of tissue. Potentially, the same principle can be applied to identify image artifacts. I will show a few right here. So you can segment those image artifacts and exclude them from analysis. As you can see, it's not perfect. Despite drawing a rectangle around this tissue section, it did not detect it. Again, we'll just draw another rectangle. Now, let's see if we can segment something like a fold. This will be a little bit trickier because it only, right now, SAM only supports rectangular annotations within QuPath. We can't use something like a brush tool and infer or extrapolate from there. To draw something like this, well, it only segments a part of it. We would have to basically repeat this process over and over again. Actually, what if we just do something a bit larger? That's promising. So if you, say, wanted to train an algorithm for identifying various image processing artifacts, well, you'll have to basically use a mix of the the wand tool and the rectangular annotation. Yeah, has some pretty promising work so far. Let's give it another go. Let's first detect tissue. Well, let's turn on SAM. Rectangle tool around tissue. Nice. Good job at segmenting it. And again, it's resolution specific, so depending on how far you zoom in, that's the level of how fine the annotation essentially will become. Let's see if we can segment this huge fold, which might be quite tricky. No, that's a very good job. I especially like this from the fact of, even if we don't use it to train our own image segmentation algorithm using these annotations, it's a great way to perform rapid quality control and remove any artifacts prior to continuing with downstream segmentation. Because I imagine in a case like this, you might not want to have cell segmentation under or being present in something like this, where, at least from my interpretation, you have a chunk of tissue folded in on itself, which can lead to a lot of false positives and issues with cell segmentation. Let's see if we can segment some other structures, potentially whatever this might be. Yeah, pretty reasonable job. What about lipid droplets? Pretty good job as well. And of course, individual cells. I don't think it has the capability to really separate cells that are just very ambiguous in terms of their nuclear border. Yeah, if anything, it seems like it's clipping towards the edge of some kind of JPEG 2000 compression artifact. But this extension is still early on in its development, so I'm sure, there might be ways to account for this. All right, so let's move on to another example. we identify whole tissue here in tissue that has a lot of empty space, presumably fat. And again, all that's being passed, at least from my understanding, is what's being shown on the screen right now. So if we draw a rectangle around this, and we need to turn on SAM again. Pretty good job. If we were to, say, try and repeat this process, but use the wand tool, which I believe relies on contrast, yeah, it's kind of tricky to get around the edges of fat-rich tissue. So, yeah, I think this is a great example where the robustness of SAM and the diversity of its training data is a great asset to have in something like QuPath. If you wanted to, say, label a tissue section. It's not going to be perfect, but you can always modify annotations using a combination of other tools. So in this case, I'm showing an example of, filling in some parts of a missing annotation. I wonder what a little segment if we highlight this entire area. Will it be the adipocytes? Probably not. Will it be this reddish area, which might be some kind of hemorrhage? Potentially. Something quite unexpected. Mix of the two. All right, let's give it another shot on a fluorescence stain section, or an immunofluorescence section. Enable SAM. And there's 3 different models. For all intents and purposes, I recommend sticking with fit H. L and B have a few, well, have fewer parameters, on order of several millions less. They might be a little bit more computationally efficient, but again, as you can see, it doesn't really take that long. Anyways, let's go ahead and enable SAM. See if it can detect tissue. Yep, as expected. Does a great job. And let's give it a little bit more of a challenging situation. I think this might be a tumor mass. Again, it really depends on the channels that are being turned on, but wow, that's surprisingly accurate. Any other histological structures that might be of interest? The lumen of whatever this might be. See if we can segment this. Not essentially the lumen, or not really the lumen, but the lumen plus the cells that outline it. What if we give it... What if we have any arteries in these sections? Without knowing the histological markers present, it's hard to say whether or not something is an artery or a different structure entirely. See if we can identify this little mass in the center, which doesn't seem to have a very clearly defined edge. Yeah, no, this is doing a reasonable job. Let's go back to some bright field sections. Enable SAM again. Not perfect, but it was a reasonable shot given the time required to actually draw that annotation, which is next to none. Let's see if we can refine this a little bit further. Perfect. And if we really wanted to omit things like edge cases, we can perform morphological operations on the annotations themselves, such as a erosion. just to remove some of these edge artifacts from any downstream analysis. Enable it one last time. And let's give it a shot at seeing if it can first identify some of these smooth muscle cells around the blood vessel. Might be a bit of a stretch here. Oh, pretty good. Let's take it one step further and detect only the lumen of the blood vessels. Excellent. And one step further, some stray erythrocytes that miraculously weren't washed off during the staining procedure. Yep, detects those as well. So where do I see this being used in practicality? Well, right now, the segment anything model, or at least the implementation in QuPath, only allows for segmenting one object at a time, so one object per human prompt. If I were to give it a cluster of cells, I don't know if I even have a DNA counter stain. Sure, here. It's not going to segment, these individual hematoxylin stain nuclei. It'll find some kind of pattern present within that image area and attempt to segment it out of whatever is considered background. The SAM model itself on like Meta actually has a lot more functionality, including the ability to use things like points or even specify areas to purposely exclude. But in this particular situation, I wouldn't see the utility of SAM as being, used for any downstream analysis with the exception of tissue segmentation. Because in some cases, you just want to identify the area of the tissue that you want analyzed, and typically it might be the whole tissue's area. That's where you would draw a rectangular annotation. But other than that, a lot of the practicality could come from the fact of being able to rapidly generate new annotations for training a model. And this is especially of use in cases where you have a very specific disease type with a very specific set of markers present in a multiplexed panel, so specific to the point where that there aren't any publicly available data sets that you can actually train your own segmentation algorithm on. And as a result, you have to rely on some domain expert, some human being who knows what those structures are and knows how to label them. If anything, this will be a tool to help speed up the labeling process such that an annotator will not have to spend a lot of time, going in and manually controlling a blood vessel. Even though this might be saving, a few seconds at most. So that was an example of me trying to do it manually. Wrong tool. Good. There we go. Yeah, SAM can do a reasonable job. And let's say we wanted to remove the lumen. I believe one approach to do this would be to draw a rectangle of the white space area. Now we have two annotations, and we can do something like a subtraction. So and voila. We've used two prompts from SAM to loosely contour what I presume is the parasite-rich wall of a blood vessel, or an artery, depending on the scale we're talking about here. Yeah, so I didn't want to make this video super long, ideally less than 20 minutes, and all the credit actually goes to, well, Ko Sugawara. He's one who developed this. I am by no means have the technical skills to build something as impressive as this. And I hope that a lot of QuPath forum members take a good look at that. All right, thanks for your time.